Hi friends, good evening to everyone. Welcome to my channel, Belagali's class. My friends, so far we have completed. Yes, my friends. First, inverse trigonometric functions. That entire chapter is completed, my friends. Then we have started with the differentiation, derivative and continuity of a function also. First, I have completed continuity of a function. I have done all examples in detail. Then started with the definition of differentiation. Then the derivatives related with what? Done in PUC first year. That is product formula, quotient formula, addition of two derivatives of addition of two functions, subtraction of two functions, all d by dx of u plus v, d by dx of u minus v, d by dx of uv, that is known as product formula, d by dx of u by v, that is known as quotient formula. Everything we have done, and two samples I have done examples also, my friends. After that, this year portion starts with derivatives of composite functions. My friends, it is told what you mean by composite function. In case of a function is a composite, then how to differentiate it. That is derivatives of composite functions type wise. Later we have done with what? Derivatives of implicit functions, derivatives of parametric functions, logarithmic differentiation, successive differentiation, all varieties of the examples we have done in case of what? Differentiation. After the completion of differentiation, even I have done, my friends, statements of the mean value theorems. There are two. One is Rolle's theorem, another is Lagrange's mean value theorem. It is simply called as mean value theorem. Statements of both the theorems are given, and my friends have done examples on Rolle's and mean value theorems. After the completion of that mean value theorem part, started with the integration. Then what do you mean by integral of a function? Definition is given. Then type wise differentiation. The basic examples. They are the examples mainly we have done by making use of what? Definition of integration. There comes some algebraic functions, trigonometric functions, exponential functions, everything, my friends, done in detail. Then comes methods of integration. One we have done method of integration by substitution, examples, everything done. Second is my friends, method of integration by partial fractions, done. After doing the partial fractions, my friends, we have done integrals of rational functions, irrational functions, those formulae connected with, my friends, examples. Everything I have done detailed, considered many examples. Almost all examples given in your CBSE textbook, everything examples we have done. Later, the third method, my friends, that is integration by parts method. Given what you mean by integration by parts and examples based on that done. Then these are related with what, my friends? Methods of integration. One, substitution. Second, partial fraction. Third, by parts. My friends, separately examples, everything done. After the completion here, in case of different integration, you have two types. One, indefinite integral. In case of indefinite integral, we are adding c, everything is explained. Now what is that c? Constant of integration. Because of that constant of integration c, the values in RHS are indefinite. Therefore, those integrals are called as indefinite integrals. Everything we have completed, my friends. Later we have started with a definite integral. Definition is given, varieties of examples using method of substitution, partial fraction, and method of integration by parts under definite integrals. Everything is done, my friends. Then properties of definite integrals. There we have done a series of properties in the form of theorems. Nearly 6 to 7 theorems. In that 6 to 7 theorems, some 3-4 theorems are very, very important, and examples related with those examples. Theorems I have done below the connected examples. Then theorems, connected examples. Theorems, connected examples. Like that, my friends, everything we have done. That completes definite integrals. With that completes integration. Yes, my friends, after the completion of all these definite integrals, next I want to start with another chapter, my friends. This is factors, my friends. In this chapter, factors, you have 1 mark 1 question, 2 mark 2 questions means 2 examples, 3 mark 2 questions means under 3 mark 2 examples. 3 into 2 6 plus 2 into 2 4 plus 1 into 1 is 1. 1 plus 4 plus 6 equal to, my friends, 11 marks in this chapter. 11 marks in this chapter. Even if you see the question papers of CET or any competitive exams, even you have fairly many examples in CET level also. Nearly 4 examples, my friends. Sometimes plus minus 1 is there. Plus minus 1 example. 4 plus minus 1 in CET level also. Connected with all this for the board exam, even for the CET, 4 examples. Then in the chapter factors, it is a very good chapter. My friends, I want to tell in the beginning itself the nature of this chapter. Very, very simple chapter. The easiest chapter in mathematics, my friends. So, this 11 is a bonus. This bonus, my friend. Even in CET also bonus examples, my friends. So, prepare nicely from the day 1, from the first video. Observe the videos carefully, prepare nicely. And one more advantage of this chapter is, already this chapter is studied in 11th or PUC first year physics. In physics you have studied a little bit even more about what these factors, my friends. Then connected with that previous background, these factors you are feeling for the PUC second year. Factors for the second year is a repetition as well as, yes, to the point of marks, it is a good productive chapter, my friends. Saying this, its background about the factors, then I will start with what? This chapter, factors, my friends. Yes, this is factors, it is told. First, I will tell about the basic concepts. Yes, my friends. There are 2 types of physical quantities. One, quantities having only magnitude. There is no direction for these quantities, my friends. For example, this speed. We do not know where we are going, but we can tell the speed of my vehicle is 20 kilometers, 30 kilometers. Those 20, 30, they are the numbers, fixed numbers, my friends. Even connected with the time, connected with temperature, connected with density. All these are the quantities, they have only magnitude. The quantities having only magnitude are called as scalar quantities. Simply, we write it in brief as what? Scalars, my friends. Then another quantity, what is this? Quantities having both magnitude and direction. Such quantities are called as factor quantities or simply factors. The scalars, factors, all these are the givens, names given by the mathematicians, like our names, Belagali, like that, my friends. Family names, like that. This chapter, there are 2 types of quantities. One quantity they have separated having only magnitude, there is no direction. These are the good examples of what? Scalars. And another examples, my friends, you know the difference between speed and velocity. About the velocity, you are mentioning the direction. I am moving with what, 20 kilometer or 50 kilometer speed towards my college, towards the temple, towards the friend's house. That towards, you are moving with what, one direction from this place to another place. Direction is there, my friends. So these are the quantities with what? Magnitude means a speed, that is 20 kilometers, 30 kilometers. Direction means the direction shows where you are moving, where you are moving. I am moving from my place to my friend's place, my place to the college. From here to there comes my friend's direction. So, such a quantities having both magnitude direction are called as factors. These, my friends, velocity, acceleration, good examples, force, center of gravity, there is a force here also. These are factor quantities, my friends. Next, another very important is what? Geometrically, how we represent factor. Geometrically, how we represent the factor. Yes, my friends. A directed line segment factor means, this is very important, a direction. A directed line segment with initial point A and end point B represents a factor AB, and is written symbolically as what? AB. This is, my friends, direction. This direction is from what? From A to B. Here it is a geometrical figure. This is the line segment AB. What is its direction? It is moving from A to B, towards this side. That gives the direction of what? Vector. Therefore, my friends, the magnitude of the factor AB is the length of the line segment here. This length of the line segment, if it is at 10 units, 5 units, 5 centimeters, that 5 centimeter is its magnitude. Then what is its direction? Its direction is, it is moving from the point A towards the point B. This gives, my friends, direction from A to B. So here, see once again, representation, geometrical representation of a vector. A directed line segment with initial point A and end point B represents a vector AB and is written symbolically, my friends. This vector AB, from A to B. That is a geometrical line segment, my friends, A to B. The magnitude of the vector AB is length of the line segment. That magnitude we write symbolically. It is what, my friends? Modulus between. Modulus means what? It is absolute value. Even the modulus of plus number is a plus, even modulus of a negative number is also what, my friends? Plus. Therefore, the magnitude of the factor AB we write symbolically, yes, modulus of AB. And its direction is from point A to B. Direction is from the point A to B. Yes, my friends, if the length of the line segment AB is A units, you mean either A centimeters or A meters, anything, in general we have taken A units, then factor AB is factor A, and magnitude of the factor AB is magnitude of the vector A. My friends, this is nothing but the representation of a factor. After that comes types of factors, my friends. Types of factors. 1. Zero factor. These factors we classify with what? Their magnitude. If the magnitude of a factor is 0, then that factor is said to be zero factor, or null factor, another name, null factor, and is denoted zero factor. Factor sign is a arrow mark. What do you mean by AA? Its initial and end points are same. When the initial and end points are same, what is its magnitude? Naturally, its magnitude is 0. 0. Same, BBCC, you mean the initial and end points are same. In that case, naturally, my friends, the length becomes 0. Distance between 2 points becomes 0. Then it is a 0 vector. Representation either 0, vector AA, vector BB, like that, my friends. It is 0 vector or null vector. Null vector. Second is a unit factor. Unit means what, my friends? 1. 1. A factor whose magnitude is 1 unit. A factor whose magnitude is 1 unit. Then that factor is known as unit factor. Unit factor. It is a factor whose magnitude is 1 unit. If factor AB equal to A is a unit factor, if you mention it is a unit factor, my friends, unit factor, then its magnitude is 1. Again, magnitude of the factor A is 1. Then comes co-initial. Initial means what, my friends? Initial point. Initial point of the factor here. This is the initial point of the factor. If there are more than one factors with the same initial point, OA, OB, OC, ABC, these vectors ABC, they have the same initial point with different endpoints. Then such factors are said to be co-initial factors. You mean their initial point is the same. They have the same initial point. Such factors are co-initial factors. Next, my friends, co-planar factors. Co-planar. Plane, it is a plane. Then the factors lying in the same plane. Factors lying in the same plane are said to be co-planar factors. Co-planar factors. Then equal factors. Equal factors. Then two factors AB and CD. Two factors AB and CD. AB and CD are said to be equal if their magnitude is same and they have the same direction. They are moving with the same direction. Magnitude is same, even direction is same. They are moving in the same direction. Their magnitude, their length is also same. In such cases, these two factors are said to be equal factors. Equal factors means their magnitude is same, even they are moving in the same direction. Same direction. If at least 5 grade, if it is different, they are not equal factors. Why? The direction is different. So, direction as well as magnitude is same, my friends. I give 2 minutes just to copy these notes. Copy these notes. Yes, friends, be quick. Copy you must do fast. Save that time. Yes, friends. Next definition is negative of a factor. Next definition is negative of a factor. Negative of a factor. Negative of a factor. Take factor AB. What is this, my friend? It is a line segment from the factor A to factor B. This, my friend. This is the factor AB. This is the factor AB. This is the initial point. This is the end point. This is the direction. Yes. The definition is negative of the factor AB is a factor whose magnitude is same as AB and direction is opposite, and its direction is opposite. Negative factor AB, negative of factor AB is written symbolically, denoted as BA, factor BA. And what is BA, my friends? BA is a negative of the factor AB. BA is negative of the factor AB. Yes, my friends. Read first, then we will come to the figure. Negative of the factor AB is a factor whose magnitude is same as AB. Magnitude as such, length as such, same as the factor AB. AB and this BA, lengthwise same. Then what is the difference? They are different in directions. This is factor AB. Then what is your negative of the factor AB? This is, my friends, direction is different. This is from B to A. B to A. Direction is different. So this is, my friends, factor BA. Factor BA, and it is opposite. Minus the factor AB. Minus the factor AB. Therefore, my friends, it is negative of the factor AB. This is factor AB. Its negative is a factor BA, whose length is same and its direction is opposite. This is, my friends, negative of the factor AB. Then, my friends, from this, what is clear? See, what is clear? My friend, this is the factor AB. This is the factor AB. What is this? This is the factor BA. What is done? AB is written BA. Direction is changed. If you change the direction, then the sign changes, my friends. It becomes minus AB. If you change the direction of a vector to BA, then the plus becomes minus and minus becomes plus. Please remember, if you change the direction of the vector AB to BA, then the sign changes, that plus becomes minus. This is about, my friends, negative of a vector, Next comes, my friends, resultant of factors. Next definition is resultant of factors. Yes, friends. This is resultant of factors. Next. Resultant of factors. It is called as resultant factor. Yes, my friends. First, I write the definition. A line joining initial point of the first factor to end point of the last factor. This line is called their resultant. Or resultant factor. Yes, my friend. But in this case, you must remember one very important point. That point is resultant of a vector exists only when end point of the first factor should be same as initial point of the next factor, second factor. For the second, next means third factor, like that. Then the resultant of factors exist. No. Resultant of factors exist only when end point of the first factor is same as initial point of the next factor. Initial point of, anyway, my friends, are mentioned here first factor. What is the next factor? Is second factor. Initial point of the next factor. What is that next factor, my friends? Second factor, third factor, and so. If you represent with a diagram, see, my friends. Yes. My friends, this is one factor AB. Then The next, this is what? The end point of the first factor. This is initial point. This is end point. Then, next your resultant exists only when, for the next factor, this must be initial point and this is the end point. See my friends, these are two factors. AB is one factor and BC is another factor. Then what is the resultant of AB and BC? It is a line joining initial point of the first factor to end point of the last factor. Here the last factor is the second factor. Then my friends, this is the resultant. This is the resultant and this is the direction from A to C. A to C. In this case, my friends, AC vector AC is the resultant. Is the resultant of vectors AB and BC. Yes, my friends, these are two such factors. End point of the first factor is same as initial point of the second factor. This must come. If you wanted another example here, we can consider more than two. This is one. This is two. Like this, my friends. What is this? This is third one like this. Say this is AB. This is the end point. Then it is the beginning point. Then this is what? C. This is D. This is the third. Then what is the resultant? It is a line joining the initial point to the end point. Initial point to the end point. Then factor AD is the resultant. Of factors AB, BC and CD. Yes, my friends, this is about the resultant of factors. What is the resultant of factors? It is a line joining the initial point of the first factor to end point of the last factor. AB, BC. A is the initial point of the first factor. C is the end point of the second factor. What is that line? AC. Therefore, AC is the resultant of two factors AB and BC. If it is more than two, AB, BC, CD like that, more than two, you can take any number. In that case, what is the resultant? Line joining the initial point A to the end point D. So, AD is the resultant factor of what factors? AB, BC and CD. And this is, my friends, about the what? Resultant of factors. This is a negative of a factor. Remember from this, if you change the direction of the factor AB as BA, the sign changes, it becomes minus the factor AB. Yes, my friends, remember these things. Then we will proceed to the what? Operations. Operations comes, my friends. First, addition of two factors. There comes two laws. Triangular law of addition, parallelogram law of addition. Now we will see what is first triangular law of addition of two factors. Next, parallelogram law of addition of two factors. One by one, my friends. Yes. First is triangular law, addition of two factors. Yes. Addition. Two vectors. Two vectors. First, my friends, first is triangular law of addition. First is triangular law of addition. Right. Triangular law of addition. Triangular law of addition, I write in brief, my friends. Yes. The addition or sum of the factors AB and BC. This is one factor AB. This is another factor BC. Again, my friends, this addition exists only when the factors are such that the end point of the first factor should be same as initial point of the next factor. Yes, my friend, if it is AB, then second factor is BC. If it is factor A, if it is factor B, then the resultant factor, my friends, resultant factor is what? AC. This AC is the sum of the two factors A and B. Then once again that resultant plays a very important role. Then the addition of two factors AB and BC, or the sum of two factors AB and BC, is a resultant factor AC. So from this map, if factor AB equal to, if factor AB equal to factor A and factor BC, my friends, it is must, end and initial must, is B, then the resultant AC, the resultant or resultant factor AC, resultant factor AC is the sum of factors AB and BC. Yes, my friend. Therefore, tell my friend, what is the sum? This is AB plus BC is factor AC. What is there? See, end and what? Beginning. Then what is your addition? It is a line joining the initial point to the end point of the second factor. So it is AC. This AC is the addition. Therefore, my friends, factor AC is the sum. This is factor A plus factor B. This is known as triangular law of addition. What is it? According to the triangular law, it is the third side of the triangle. If these two represents the two sides of a triangle, AB and BC, then the third side, what is that third side? AC, which is known as the resultant of the factors AB and BC. This third side represents the sum of these two factors A and B. AC equal to A plus B. This is the definition, my friends. Definition. Yes, copy it, my friend. Copy it. From this, my friends, we get one very good example, or we can say the very good result. Result. It is a basic result to represent a triangle. Yes, my friends, I reference with this itself. Yes. Yes. Tell my friends, if AB factors BC, CA, we have taken my friends in order AB, BC, CA. 5 N initial represents the three sides of a triangle. Three sides of a triangle ABC. Then prove. One more question, my friends. Then prove factor AB plus factor BC plus factor CA equal to zero factor, my friends. Zero factor. It is a one mark question. Good example actually. Even sometimes initially beginning it used to appear even for CET also. The value of this equal to dash. It is nothing but zero factor. Yes, my friends. This is the triangle ABC. This is the triangle ABC. This is A. This is B. This is factor AB. This is a C. This is factor BC. What is this? This is CA. Factor C. AB, BC, CA. Or even you can take, my friends, this is the first factor. This is the second factor. This is the third factor. Yes. Now tell my friends, what is AB plus BC by triangular law? Yes, I write here. By triangular law, we have factor AB plus BC. Tell what is this, my friend? AB plus BC is AC. What is this? It is a factor joining initial point of the first factor to end point of the second factor. Initial point A, end point C. This is factor C. I want to change its direction. This AC, if I write to CA, then negative of a factor, the sign changes. My friends, I told here, what is that? BA, factor BA is minus AB. That sign changes. If you change the direction BA to AB, this plus, my friend, this plus changes to minus. Here. AB plus BC is AC. If you change from AC to CA, the plus here changes to minus. If it is minus here, it changes to plus. Sign changes. Take this side. If you take this side, my friend, this is factor AB plus BC plus CA. Taking this side, that minus becomes, this is zero factor. I tell my friends, LHS is sum of the factors. LHS is a factor part, therefore don't write 0. If you write simply this 0, it is a scalar quantity, it is not a factor. If you mention this bar, it becomes a factor, 0 factor. Therefore, this RHS is not 0, scalar 0, it is a factor 0. AB plus BC plus CA is 0. Or even, my friends, you can tell factor A plus factor B plus factor C equal to 0 factor. Factor C equal to 0 factor. Hope, my friends, it is clear. Yes, my friends. Next comes parallelogram law of addition. This is triangular law of addition. Second is parallelogram law of addition. I hope it is clear, my friends. AB, BC are the two vectors. Then sum of these two is the resultant AC. If this equal to A, this equal to B, then the resultant factor AC is the sum of these two factors AB and BC. Therefore, by definition, AB plus BC equal to AC, or AC equal to factors man. What is AB? Is factor A. What is BC? Is factor B. Or AB plus BC is AC, or this AC is nothing but A plus B, my friends. Making use of this triangular law of addition. Triangular law of addition. This is a small example, good example. Yes. If AB, BC, CA represents the three sides of the triangle ABC. This is triangle ABC, AB, BC, CA, taken in order. They represent the three sides of a triangle ABC. Then this is true, my friends. Sum of these three sides represented in the form of factors. Factor AB plus factor BC plus factor CA equal to 0. This itself becomes the test for what? If you add all the three factors, if you get it as what? 0 factor, then those three different factors represents sides of a triangle ABC. Sides of a triangle ABC. If the sum is not equal to 0, then those three factors doesn't represent the sides of the factor ABC, sides of the triangle ABC. Therefore, to say what? This is a triangle. Then we have to add what? The factors related with the sides of a triangle. If the sum of those three factors is 0, then those three factors represents three sides of a triangle. If it is not 0, then those three factors doesn't represent the sides of a triangle. In future, to say that these three are the factors represents the sides of a triangle, what is the test? Their sum must be 0 factor. Then only these three factors represents the three sides of a triangle. This is by triangular law of addition. Yes, how to prove it? By triangular law of addition, direction AB plus BC. Initial to end, this is AC. Change the direction, AC to CA, this plus becomes minus. Bring this side, plus CA equal to 0. This way. If sometimes they give, instead of AB, BC, CA, they give, if the factors A, B, C represent the three sides of a triangle, then the value of factor A plus factor B plus factor C equal to dash. They give in the beginning, my friends, 0. It is not the answer. Which is the answer? Factor 0 factor is the answer, but from scalar 0. Remember, my friends, this is about triangular law of addition. Next is about parallelogram law of addition. Second parallelogram law of addition. This is triangular law. Yes, friends. Next is parallelogram law of addition. Parallelogram law of addition. The statement of this, my friends. I write first the statement. If factor OA is taken as factor A and factor OB is taken as factor B, are the two adjacent sides, are the two adjacent sides of a parallelogram, I write in symbolic, my friends. Parallelogram OA CB, it is a parallelogram OACB. First I draw the figure, my friends. Yes, this is the parallelogram. Yes, this is O, this is A, this is OA equal to vector A, this is B, this is OB equal to vector B. Then you have to complete the parallelogram OACB. Then tell my friends, what is this? OC is the diagonal of this parallelogram. OC. Yes, my friends. This OC is the sum of these two factors, my friends. This OC represents the sum of these two factors. This OC. Yes, my friend. Directly I write the diagonal OC of the parallelogram OACB represents the sum of the factors OA and OB. Or, my friend, factors A and B. Yes, my friends. If OA equal to A, this, OB equal to B, this are the two adjacent sides of a parallelogram OACB. Then the diagonal OC. What is this OC, yes, my friends? This is what? This is the diagonal co-initial with factors A and B. Means OA, OB, OC, they are the co-initial factors. Their initial point is same. Then such a diagonal represents the sum of the factors A and B. I have written the same. The diagonal OC of the parallelogram OACB, which is co-initial factors with factors A and B, represents the sum of the factors OA and OB or factors A and B. Therefore, my friends, by parallelogram law, we have factor OA plus factor OB is the diagonal whose initial point is same as these two, or, my friend, diagonal OC equal to sum of the factors A plus B. Yes, my friends. What is your observation? Parallelogram means it has two diagonals. Yes, my friend. OC represents what? OC represents A plus B. Then what is the another one? Another one is the diagonal BA. This, my friend, I am not taking AB. Diagonal BA. Yes. This diagonal BA represents the difference of the factors A and B. What is the difference of factors A and B? A minus B. The other diagonal B, factor BA represents the difference of factors, factors A and B. Factors A and B. Yes, my friends. Again by parallelogram, the diagonal BA, other diagonal, is nothing but difference of factors A and B. This represents A minus B. OC co-initial A plus B. Other diagonal, not AB, BA. Diagonal BA represents the difference A minus B. Definition, my friends. Definition. This is known as parallelogram law of addition. Parallelogram law of addition. Two. One is a triangular law. This is parallelogram law. Yes, copy it, my friends. So I'll explain once again. Yes, friends. What is parallelogram law? If OA and OB are the two adjacent sides of a parallelogram OACB, then the diagonal OC, whose initial point is, it is same as initial point of factor A and B. Yes, co-initial factors. Factor OC represents what? Diagonal OC. Factor OC represents the sum of the factors A and B. Sum of the factors A and B. Therefore, by parallelogram law, OA plus OB is the diagonal OC, or OC equal to A plus B. Then, what is the other diagonal BA? Represents the difference of factors, my friends. Difference of factors A and B, that is very important. Difference of factors A and B, you mean A minus B. This is known as parallelogram law of addition. Yes, my friends. Then comes, based on this, two properties. One is commutative property, another is associative property connected with factor addition. Those two properties and rest of the factors I do it in the next video, next class, my friends. Till then, have a nice time. Nice time with factors, my friends. Okay? Yes. Thank you very much. Bye. Goodbye, my friends. Namaste, namaskara, namashinnu, my friends. Enjoy. Good day.